Today we'll discuss about a differentiation. Okay. So what is a differentiation? Differentiation is something that gives the rate of change, the rate at which a particular function is varying. Okay. For example, so in an x and y plane, in a coordinate plane, I have a line passing through this one, passing like this. Okay. So this line is a straight line. What is the general form of straight line equation? Y is equal to mx plus c. Okay. For example, assuming this is rising as we move from left to right. This is rising or falling? Rising. So let's assume the equation for this straight line is y is equal to 3x plus 5. Okay.
Yeah.
What is the slope of this one?
3.
3. Okay. What is the slope of this one? It's a 3. Okay. So y is equal to 3x plus 5. This is the equation. Differentiation of x to the power of n. Differentiation of x to the power of n. This is x to the power of n with respect to x. So what do we have here? X. Okay. Differentiation of x to the power of n with respect to x. This is how you have to read this whole term. Differentiation of x to the power of n with respect to x is equal to the power will come here.
n times x
Y
to the power
equal
of n minus 1.
d
No,
it won't.
they are not variables. This whole thing is called a differentiation.
Each of writing differentiation will just put d. n into x to the power of n minus 1.
n minus 1. See, the power of x is coming as a multiplier here. X to the power is getting reduced by 1. Here previously it is n, here it is n minus 1. Okay. Similar lines, let's try to find out d by dx. Differentiation of x to the power of 5. Differentiation of x to the power of 5 with respect to x. So, what will be the differentiation of x to the power of 5?
It will come 5x to the power of 4.
4.
Yeah.
5. Here, x. The power is reduced by 1. Okay. 5. The power has come here. X to the
What
power
is
of
x?
x can be anything. But one thing that you have to remember
Then
is
x
x-axis should be here.
cancel. But
No, this is not a this is not an expression. This is a way you read. Okay, this is all together. D by dx is a differentiation of
okay.
something with
That's
respect
not
to
like
x.
algebra.
Differentiation of this thing with respect to x. Okay. Similarly, d by dx of x. What does it mean? Like differentiation of x with respect to x. What is the formula?
It will be x. It will be 0.
No. You can
Is
assume
the
the
x
power
as power? Is the x power or is it like a
1.
base?
x.
Then
The
then
power is 1.
we can take power as 1.
Mm,
1 into
mm,
x to the power of
mm.
0.
0.
Yeah,
That
that
is
is
1.
what is 0?
No, x to the
1.
power of 0 is 1. It's not
Oh,
0.
okay.
1 times
Yeah,
1
I
into-
got it 0.
1 into 1, yeah, no. X to the power of 0 is 1.
Okay.
Okay? The standard thing, like you can simply remember it. Differentiation of x with respect to x is 1. Differentiation of x with respect to x. Differentiation of t with respect to t. Differentiation of t with respect to t.
It will
Is
be
it
1.
1 only.
Yeah.
Same thing. Same as here. See here. Differentiation of x with respect to x. Differentiation of t with respect to t.
And that thing like the.
It doesn't matter. Like if you want, you can put this here also.
Oh.
There's no difference whether you put it here, whether you put it differently.
Yeah.
Okay, just to isolate what we are differentiating, I just give some separation. But you can also club it with this. Differentiation of t with respect to t is again 1. Okay, the main formula is this one. Okay, these things you can derive it from this formula. Here also we thought x power 1.
Mhm.
The 1 has come here, x to the power of 0. Okay. Similarly, differentiation of 5 with respect to x. What is that one?
Is 5
How we can write 5?
5x to the power of 1.
No.
Yeah, then it will
5
come
can be written as
5x.
5 can be written as, you can also think 5 as 5x to the power of 0. You can write it, right? You can
Yeah.
think it like this, right?
Yeah.
Okay. Before that, I will tell you one more. So let's go to that one. Yeah. For example, differentiation of x to the power of 4. Sorry. Differentiation of 7x to the power of 4 with respect to x.
Means that
In such case, the 7 is a multiplier which can be brought here.
7 into
7
4
into,
into x to the power of 4
we
minus 1.
give it step by step. 7 into x to the power of 4. Both are same.
So 7 into
Okay.
4 into x to the power of 4 minus 1.
Okay. Both are same. Whether
Yeah.
okay. 7x to the power of 4. Differentiation of 7x to the power of 4 with respect to x is equal to 7 into differentiation of x to the power of 4 with respect to x.
okay.
The only thing is that whatever is the multiplier here we brought before. 7 into what is the differentiation of x to the power of 4?
4 into x to the power of 4 minus 1.
3.
3.
The power is getting 1 less.
That's what I told you.
Yeah. Okay, that is equal to 28 x to the power of 4.
X to the power of 3. 3.
Sorry, x to the power of 3.
Yeah.
Okay. So anything like if something is multiplying this x to the power term, then that multiplier you can brought it to before. Okay. Okay. Next one. So differentiation of 5 with respect to x.
It will come 7 dx. No,
What's your
we
question?
have to think x to the power of
1
0.
into 5 to the power of 1 minus 1.
No.
Is that the question?
Yeah. What is the differentiation of 5 with respect to
It will
x?
come 5 dx to the power
The
of
same thing
0.
can be written as d by dx 5 into x to the
X
power
to
of
the
0.
power
Can
of
I write
0.
like this?
Yeah.
Will it change? There is
No.
no change, right? This and this are same. The reason
That's
is
what I was
Shouldn't it has to be like x to the power of something? In that case, we can think x as 5 now there.
let me explain. What is x to the power of 0? 1. 1 into 5? 5.
5.
Same thing, right? D.
No,
5
I'm
dk.
telling that you can take 5 as x now there.
5 as x.
Yeah.
What do you
Take
mean
it
by
like
5
that.
as x?
5
Normally,
like-
you got that d by dx, like d by dx 5x to the power of 0 now. You can, instead of that x, like you can think the 5 as x now before.
Yeah.
Here.
Up.
Here.
Or like
5 as x.
if
Right?
So it will
Why?
have
Like
it will
x can be anything, right?
be, it will be 1 into 5 to the power of 1 minus 1.
I did not understand what was that.
or no like
No, first of all, what is the
if it
differentiation
like
formula? N
3
into x to the power of n minus 1. Na?
Yeah.
N. We can.
What is n here?
n is 0. 0, yeah.
Okay. I'm telling like, is there any difference between this and this?
No.
Both are same. The reason is
But you can also think d 5 to the power of 1. 5 to the power of 1.
5 to the power of 1. Yeah, I can also
It
think
is the same. That's what I'm telling.
Okay.
If it's
okay.
like that,
Okay. You put 1, you put 1 here. What is there? There's no difference.
why are you putting x to the power of 0?
Because x to the power of 0 is 1. You know the formula of x to the power of n. That is why I'm putting it like this. Because there is no x here. That is why I brought some x.
But we can think that x has 5 only now.
Or
X has
like
5. X we don't
if
know.
it is 3 plus
Oh, in any
x
question we don't know x.
We don't know
3
x.
or like if it is 3 plus x equal to 3, then x is 0 no in that case.
In that case.
Ah,
If it,
then in
but there
this
is no
one-
equation here. Right?
Yeah, then equal to is there.
Equal to, but this one and this one I rewritten the same thing. Both are same
We
only.
should always think the number as n.
The power of x should be treated as n.
Okay.
Okay.
Then what is 5?
See here, what is 5 here?
5 is an
5 is something that is multiplying x power, multiplier. So that 5 can
it's
be
like
brought to
C. Like
brought before. Yeah. Okay. Okay.
What
There's
if
no
there is a question like this? D 5 to the power of 2 by dx.
5 to the power of 2 by dx.
What is the difference?
That is nothing but a d by dx of 25. That's it. Differentiation of 25 with respect to x. That's it. There's no difference. Okay.
Can't you tell it like this?
This is not a n.
2 into
Nothing is n. This is all some constant.
2 is an n. 2 is n.
no, the n is x to
N
the
is
power
x
of-
power. There is no x here. Okay, there is no x here. Same thing can be written as this way. There is no difference because x power 0 is 1, 5 into 1 is 5. Same thing. Differentiation of 5 with respect to x, which is equal to 5 can be brought to before.
N
5.
is always power of x, no?
N is always power of x. Remember, n is not anything. N is always power of x in this formula. Okay. N is not something like
So n
here
in
we
this case is
here-
0.
here x to the power 5 we multiplied with 7. It does not mean the 7 is n. Okay, 7 is just a number in this case.
In this case, n is 0.
No,
because-
in this case n is 0.
N is
Yeah,
0.
correct. Yeah. 5 we brought it
It
before.
is 0.
No,
the
we'll put one more
Answer
step.
is 0.
We'll put one more step here.
Yeah.
5 into differentiation of x power 0 with respect to
Answer
dx.
is 0.
5 into what is a n into x to the power of 0 minus 1. Because we have 0 here,
Yeah.
whole thing will become 0. Okay.
See, I said
Key
no.
things to remember: differentiation of any constant with
I
respect to
said
x.
it is
0. Differentiation of constant
Mhm.
with respect to x or with respect to t, with respect to y, anything.
Then where is 1?
Hmm?
Or dt by t? There is 1.
Yeah.
What is the difference between dt by dt and d5 by dx?
d
dt by dt.
dt by dt. Differentiation of t with respect to t.
This is differentiation of
Yeah, 5
5.
with respect to x. There is a difference, right? This variable and this variable is same, but here there is
5
a
is a
constant.
constant.
5 is a constant.
Multiply.
Here this is a variable. So differentiation of constant is 0. Okay. Differentiation of a variable with respect to same variable is 1. Differentiation of x with respect to x is 1. Differentiation of t with respect to t is 1. Differentiation of x to the power of n with respect to x. This is important, with respect to x only.
Yeah.
Okay, there are a number of formulas, but this is the one of the formula that we often use. Differentiation of x to the power of n with respect to x is n into x power n minus 1. Where n is here power of x. Power of x, remember. Okay. And also the base here is x, and here also we are doing a differentiation with respect to x. That's important. Okay, there may also be case like a d to the power of differentiation of n to the power of x with respect to x. This and this is not the same because here x power n, here n power x. Okay, the both are not same. Don't get confused. Okay, differentiation of x power n with respect to x is equal to n into x power n minus 1. Okay.
Means up one is also same as wait, x n, no, like up one, like
This one.
yeah, that is also same as x n and x minus 1,
No.
like
that's not-
x n and up.
No, it's not same.
Okay.
It's not same. Okay, the formulas for this one is different, but we'll discuss in later sessions. Okay. And also, for example, this is another scenario where, for example, if you want to differentiate 7x to the power of 4 with respect to x, in such case 7 can be brought before. I brought the 7 before. Differentiation of x to the power of 4 with respect to x. 7 into, this is normal formula. Differentiation of x power n with respect to x is equal to n into x power n minus 1. That is equal to 7 4s are 28 x cube. Okay. Now okay, I'm going to leave just this formula. What is the differentiation of 7 with respect to x?
7 7x to the power of 6.
Yeah. 7x to the power of. What's the formula again?
What is the differentiation of 7 with respect to x? Sorry, what is the differentiation of 7 with respect to x?
7.
No, we can.
to the Wait. 7 times 7 into. Wait, I know the answer. 7 into. That can also be written as d by dx
It
into
will
7
come
into x to the power
0.
of 0.
Yeah, this can also be written as
It will come 0.
7 into x to the power
0.
of 0. Now bring the 7 outside.
It becomes
And
7.
0
7.
x to the 7
7.
0 into x
See,
to the power of
see, I said it
minus
0.
just
0.
to simply remember constant.
Constant.
Differentiation of a constant with respect to any variable is 0. Simply remember it.
I said
okay.
0.
This is
Yeah.
how we derived it, but you can simply remember it.
Yeah.
0. Okay.
Yeah.
Similarly, differentiation of y with respect to y.
1.
1. Okay.
1.
1.
Yeah,
Okay,
like
yeah.
if it does same thing up and down, it will be 1.
Yeah, good. Yeah, that's a simple way to remember. Up and down, if it is same thing, that is fine.
Yeah.
Otherwise, if you want to derive it, you can also derive it. The same, you can consider this as 1. Okay? 1 into y to the power of 1 minus 1, that is equal to 1 into y to the power of 0, that is equal to
No,
1.
it will come 1. Yeah.
Okay. Now,
The slope
yeah. So, what is the equation of this straight line?
y
Y is equal to yx,
3 y is equal to mx plus c.
y is equal to 3x plus 5 in this case. Because it has a positive slope, so I took some positive number. Okay. And because this is 5 here, it
It
is
means
cutting a
y-
y-axis at 5. This can be 5. This can be, yeah, 5, 4, 3, 2, 1. Yeah. Okay. What is the equation? Y is equal to 3x plus 5. At what point it is meeting x-axis?
X-axis.
If you want to know that, you just equate pi to 0.
Y
Yeah,
to 0.
y
Because
to
at
0.
every point on x-axis, we have y value as 0. What is the y value here?
It will be
What is the y value here at this point?
3.
0. See, what is the y
Oh,
value
okay,
here?
okay, yeah. See.
What is the y value here?
0.
What is the y value here?
In that, it will be equate x to the 0.
Yeah, 3x plus 5.
Yeah.
Okay, x is equal to minus
Minus 3.
5 by 3.
Minus 5 by 3.
Okay.
Minus 2.5. Is it?
Yeah, minus 2 and a half. Sorry, 1, 2 by 3. Minus 1 by 3. 1, 2 by 3.
3.
Okay.
Yeah.
So if you equate to 0, that will give you the roots of the equation. If you equate this one to 0, if you equate y to 0, then it gives the roots of the equation. Alright. So it has a slope. What is the slope of this
3.
equation? 3. The slope between these 2 points is 3. The slope between these 2 points is 3. The slope between this point and this point is also 3. You take any 2 points. To find out the slope, we need how many points?
2.
2 points. Okay?
Yeah.
Okay. 3 points are given. Can you find out the slope?
Yeah, we can. Like, if we are in the straight,
Mm.
he can.
We can, yeah.
If they are in like a straight run.
Yeah. You can find out the slope. For example, if 3 points are given, for example, there are a point here, a point here, a point here. You can find out the slope between these 2 points. Between these 2 points, you can find out the slope. Okay, but you cannot find out all 3 points. You cannot use all 3 points at a time to find out the slope. If this slope between these 2 points and slope between these 2 points is same, then you can say they are in straight line.
Oh, okay.
Okay, not like this. You don't find out the slope between these 2 points and between these 2 points.
Yeah.
Okay, find out the slope between these 2 points between this. Okay.
Okay, but if that another one is like up like straight one.
Yeah, if both
then,
slopes are same, then you can say they are all in a one
straight
straight line. Okay, if they're not, if the slope is not,
it's not straight line.
yeah, between these 2 points find out. Between these 2 points you find it out. Because you are finding out the 2 slopes.
Yeah.
In both the cases you have to keep 1 point common.
Yeah, like it may be at point like.
Or else you find out the slope between this and this, between this and this, between this and this.
No, it can't come by that.
Why?
I don't think it will come.
It will
Because
come.
if it is like the same one. Okay, yeah.
Okay. What I'm
Are you telling me will it come like a straight line?
sorry.
What is your question for those 3 points?
No, I'm just telling. Like if 3 points are given, can you find out the slope?
Slope will be different at different
Yeah,
points.
at different points. Yeah. So you have to find out the slope. All you need is a 2 points. All you need is a 2 points. So if 3 points are given, you have to find out. Take 2 points at a time, and then find out the slope. Okay. If a slope between this point, and this point and this point is same, then you can say they are all in a straight line. Okay. All those points are on a straight line. Alright, we little deviated. That is fine. Yeah. Okay. So what is the equation here? Y is equal to 3x plus 5.
Yeah.
Okay. Let's differentiate this one. What is the slope of this one? This line? 3. Okay. We know that the slope, because it's in y is equal to mx plus 3 form, slope is 5. Let's differentiate this with respect to x on both sides. dy by dx is equal to d by dx of whole thing. 5. Okay. We differentiated. Simply put a d by dx here. Simply put a d by dx here. There is no confusion, right? Both sides we can do. Whatever operation you want to do, you can now do it in any equation. Just like on both sides add 5, both sides subtract 5, both sides multiply with 5, like that. Okay. So this one you can apply this rule, d by dx of 3x. This we are applying differentiation on 3x plus we are also applying differentiation on 5. Are you clear here? Okay. Here, what is the differentiation of 3x with respect to x? 3 can be brought here.
Yeah.
Then it becomes dx by dx.
Okay.
Then what is the differentiation?
3 into
1. Differentiation of x with respect to x.
It will come 3.
1. Yeah. 3 is here before, so it will become 3.
3.
What is the differentiation of 5 with respect to x?
wait,
5.
how did 3 come again?
3 comes here before.
And it will come 0.
Then it becomes a differentiation of x with respect to x.
It will come 0.
0. Equals 0.
And it will come 3. Yeah.
3. Okay. So what is the slope of this equation? 3.
3. Oh, it came actually.
Yeah. Any equation, if you differentiate,
But we can't see the starting of the equation.
What is that step there? D by dx.
here,
There, up above.
here. So I differentiated y on the left side. I also differentiated the whole thing on the right side. D by dx, I put a d in front of y. I put a d by dx. In front of whole thing, I put a d by dx. I differentiated on both sides with respect to x. With respect to x. Okay. The way we read it is important.
Afterwards, you expanded.
I expanded it. Differentiated on 3x plus I differentiated on 5 with respect to x. Okay, everywhere I am reading with respect to x. That's important. Okay. with respect to what variable you are doing is important. Okay. So
If the both the variables are the same, then it will be 1.
then it will be 1. Yeah. Then it will be 1. Okay. So the differentiation gives the slope of the any given equation.
Yeah.
Okay. So this equation y is equal to 3x plus 5, which represents a straight line equation. When you differentiate it with respect to x, this equation, you will get a slope of 3,
Yeah.
which is matching with the.
But we can tell the slope in like starting only. No?
Good thing. Very good. Yeah.
What is your question?
We can tell the slope at the very beginning only. This is simple. Y is equal to 3x plus 5. Everybody, even small kid also knows it. The slope of this unit is 3.
Yeah.
No bother. Yeah.
Then
Okay.
Then
Excellent.
To
Yeah.
check it.
Then
maybe.
what
Like,
happened?
why we have to apply the differentiation? Okay. Okay.
Maybe to check like recheck
check if
again.
Okay. Why to apply this whole differentiation? Why should we learn all of this? Excellent question. Yeah.
it's just a way to like know if the
Right.
differentiation is the same as slope.
Okay. For example, I'm going to arrange this also. But I'll write this key formula here. Differentiation of x to the power of n with respect to x is n into x to the power of n minus 1. Okay. I have a curved line passing like this. Okay.
Yeah.
Let's assume this is 3. Should I make it even simpler? Let's make it even simpler.
Okay.
So we pick up this one after. Okay. Okay. For example, a line is given like this. Certainly, this is not a straight line. Okay. So all of us know that this is a curved line.
Hmm.
Okay.
Yeah.
It is meeting x-axis here at 1
Hmm.
and 2, 3, 4. Yeah. 4. Okay. Minus 1 and minus 4.
Yeah.
Okay.
Yeah.
It's meeting x-axis at minus 1 and minus 4. Minus 1 and minus 4 are the roots of this
Roots of the no
equation.
the
Roots of this.
roots are x plus 4 and
No,
x.
the roots are minus 1 and minus 4. It's factors.
Oh. Okay.
Okay.
Okay. Yeah.
This line represents a quadratic equation because it has two roots, minus 1 and minus 4.
Yeah.
Okay.
Yeah.
Okay. And this is y-axis and this is x-axis. What are the factors of this one?
X plus 4, x plus 1.
Yeah.
Isn't it? X plus 4, x plus 4,
X
And
plus 1.
x plus 1. Okay?
Yeah.
The roots. If you expand this one, you will get the
The
quadratic
quadratic equation like x
quadratic
square.
equation.
X square plus.
X square plus 4x
No, x
plus
square.
1x.
X square.
Sorry. X square
Plus
4x plus 1x. 5x.
5x.
4 into 1, 4.
Yeah.
Did you understand?
Equal to 0.
If you equate it to 0, you'll get these roots. But if you equate it to y, you'll get the whole curve.
Okay.
Okay,
Yeah.
if you equate it to 0 and solve it, you will get x minus 1 minus 1. Because y you equating on y on x-axis, this point is, what is the value of y here?
It is high.
No, what is the value of y here?
Oh, is 0
What is the value of y here?
minus.
Wait.
No, it's not actually high.
What is the
Is
value
that
of y?
y means y-axis or y is equal to mx plus c? That y.
What is the value? This is x-axis, this is y-axis.
Yeah.
What is the value of y here?
Oh, it is
Oh.
in. No, it
Zero?
is
0.
infinite.
What is the value of here?
Zero.
0. If you equate this to 0, you'll get these two roots, -1 and -4.
Okay.
If you equate it to y,
It will come like
this
the
whole
whole
thing, it
line,
represents the whole thing,
whole curve.
whole curve.
Mhm.
Okay, everywhere. Using this equation, you can find out here what. If, say for example, here y, it could be 5. If you equate it to 5, you will get what is the value of x.
Yeah. Okay.
Okay, understand?
Mhm.
If you equate to 0, you'll get the roots. For example, if you equate to 0, if you solve it, you'll get these two roots. Why are you equating it to 0? Because at these points, you'll get a y value is 0.
Plus 0.
At this point, y value is 0. That's why you're equating to 0. Otherwise, if you equate it to y, this is an equation which represents the whole
whole curve.
curve. Okay.
Whole equation.
Okay.
Yeah.
So now we are differentiating whole thing with respect to x on both sides.
dy
dy
by
by dx
dx.
is equal to d by dx of whole thing. X square plus 5x plus 4 whole expression.
Okay.
This can be expanded.
Yeah.
Did you understand, Tejashni?
It
From
will
here to
come.
here.
It will come equal to d.
We differentiated on both sides with respect to x.
Yeah.
d by dx, d by dx. Y I put here, and this whole expression I put here.
Mhm.
Okay. So
It will come d
by dx x square, differentiation of x square with respect to x,
e by
dx 5x,
yeah, and d4. It will come 0 there, like that one.
okay,
It will come 0.
yeah, okay. So what is the differentiation of 2x x square with respect to x?
It will come
2 into x to the power of 2 minus 1.
Yeah, x, 2 into x to the power of 1.
yeah.
Or x to x.
Yeah. What is here? 5 can be brought before.
Mhm.
5. What is the x?
5. Yeah.
5 into 1 in 5 into 1 into x to the power of 1 minus 1.
1 minus
It
1
is
is
5.
it's 1.
Yeah. I
5.
said it's
5 is here, 5. Yeah.
And plus is 0.
What is the differentiation of
Zero.
4 with respect to x?
0.
Differentiation of 4
Mm,
with respect to x?
0.
Is it 0?
0. Differentiation of constant is 0. With respect to any variable.
Yes.
Remember that. These are the key things. Differentiation of x with respect to x is 1. That is why 5 into 1 we got 5.
Mhm.
Differentiation of constant with respect to any variable.
Mhm.
Here differentiation of x with respect to x. Differentiation of one variable
Mhm.
with respect to same variable.
So,
The power of the variable should be 1. Okay, it should not be 2, it should not be -2, it should not be -1.
And if it's 0,
If it's 0,
then
then it becomes a
0
constant.
minus 1 equal to
But we have
minus 1.
d by dx of 4. This can be written as d by dx 4 into x to the power of 0. Na?
Yeah.
Can we
Yeah. And the
4 will become
0, it will come like
4 into, what is the formula for this one? N into
mhm.
0 into x to the power of 0 minus 1. Because we have here 0, everything is becoming 0.
But what if it 1 in place of 0?
If we have a 1, this becomes like
No,
this.
no, like only like down of it.
What?
Yeah, in that if it
Why 1 will be there? Because the 0 is here, na? The 0 will come here
Oh,
always.
means it can't be in.
It can't be 1.
Okay.
That is why I said differentiation of constant with respect to any variable is 0 eventually.
C is a constant.
Okay.
so the answer will be 2x plus 5.
Answer is 2x plus 5. Okay. This tells what is the differentiation. Previously we concluded that the differentiation gives the slope of the
Yeah.
line.
Then
Then
we
is it the
can't
slope of
find the slope of like a curve
Curved
shape.
line.
No?
Yeah, correct. We can't find the slope of the curved line. I
Yeah.
agree. But assuming there are 2 points are given here, this is 2 points.
Yeah.
Can they be considered they are a straight line?
No.
yes.
No.
Yes.
They're two close by points.
Yeah, but
Yes. That's what we do in
even though
integration,
it
right?
came in those like No, like
That's what we
even
do
though-
in integration, right? We divide it into small boxes. So if you take it as like a rectangle, one perfect
Yeah.
rectangle, It'll-
yeah. We can
it's the
take
same
like
as
these 2 points. Like if you
integration.
take 2 small points,
No, it's not a stilt. It's still the straight line there.
that
Make it
is why
really
you
smaller.
make even the smaller 2 closest points.
I understand what
Okay.
you're trying.
Okay,
Mm.
so that they become a straight line.
Mm.
I know, like even this point, we cannot consider this as a straight line.
Mm.
But we take the 2 closest points, like just 0.001 and 0.002. That much close.
Oh, okay. Yeah.
Okay, that much close points you take it, and they can be considered as a straight line. That is why the slope here is not a simple number. The
It's
slope
like
is
in
varying.
the x terms.
The slope is also varying with respect to x.
Mm.
For example, if you put x as 1, you will get different slope. If you put x as 2, you will get a different slope. If you put x as 0, you will get another slope.
Yeah.
Get x as 10.
Yeah.
That is why it is having a variable slope.
Mm.
It is varying. The slope is varying, keep varying at different points.
Mm. Yeah.
Okay.
Okay.
That is why in the slope you got a 2x plus 5. Whereas previously, how much is the slope? When we differentiated, you got a slope of 3, which is
Yeah.
matching with the slope of the straight line.
Yeah, it's like so straight. So,
So
the x
there,
is
wherever
zero.
you 2 points you
Zero.
take it,
That
always the
means
slope
this
is
is a differentiation of that small line, huh?
no, the differentiation of the whole expression. Whole expression.
Okay. Yeah.
Okay. Whole expression differentiation is 2x plus 5.
Mm.
Okay. Now you tell me,
Mm.
in this curved line, where do you think
Mm.
the slope is the lowest?
In the peak
At the region.
point, like the peak one.
Here see,
Yeah.
just come down and slow it down,
Yeah,
down,
it's like
down,
so
down, and
peak
stop, and
and-
then you returned it. And at this
No,
point, it is stopped.
It has like so peak edge, like.
Okay. So at this point, we thought slope is 0.
Yeah.
Okay.
Yeah.
So what is the slope we got here? 2x plus 5. Let's equate that to 0.
Okay.
2x plus 5 is equal to 0. I am equating slope to 0. Okay, not this equation to
Yeah.
0. Okay, if you equate this to 0, you'll get the roots.
Oh, okay.
That's about the roots. Okay,
Then
that's about the whole equation. If I
It will
equate,
like the plane.
yeah, if I
number.
equate this slope
Mm.
to 0, I'll get the point and the curved line where the slope is
Usually,
0.
if you differentiate y to 0, 2x plus 5 is the slope, huh?
2x plus 5 is the slope.
Oh,
It is not.
Okay.
It's
not the line
It's
equation.
not the line equation.
Mm.
Okay.
Mm.
What is the line equation then? That one.
Up.
What is the line equation?
Up one. Like.
Line equation is this one. Line equation is y is equal. The curved line equation is y is equal to x square plus 5x plus 4.
Mm.
2x plus 5 is equal to 0.
Mm.
I equated the slope to 0.
Mm.
What is the value of x from this one? 2x is equal to minus
Mm.
5. X is equal to minus 5 by 2.
Minus 5 by 2.
Minus 2, 1 by 2.
Oh,
Isn't it?
oh, the same one we got it like the previous one, like.
No.
Yeah.
Yeah, maybe
I
somewhere
know.
else.
Okay,
but
okay,
yeah.
yeah.
Okay.
Mhm.
Okay. The slope at x is equal to minus 2.5 is 0.
Yeah, like
Let's
the
compare it. Let's see it.
I know
This is minus 1 and minus 4. What is the middle point here?
there. Yeah. If we go like straight
No,
down, it
what is the
will be,
middle point here? You just tell me.
minus 2.5.
Exactly. Minus 2.5 is the point. Middle point is minus 2.5. At this point, it reached out the bottommost.
Yeah. Okay.
Do you agree now?
Like if we on that higher axis also, no, like he don't know how
Yeah.
deep it's going.
Exactly. Yeah. If you want to know how deep it is,
We have to.
You have to
do
equate x to 0?
Mm.
Is it that?
I equal
No,
to
no,
0.
no, this is only the slope. Okay. Don't equate the x.
Okay,
Don't put x as 0.
Yeah.
But instead, at this point of x, it reached the bottommost where the slope is 0. I equated the slope to 0, then I got a point x as minus 2.5.
Mm.
Okay, at x here, if I
But
put here,
if you want to know the how deep it's going, we have to equate y to 0.
No.
Yeah, because it
No,
will
not
be
y
like
to 0. If you equate y to 0, you'll get this point and this point.
Yeah.
Oh,
Where
okay,
it cuts
okay.
x-axis.
Where it cuts axis, because these 2 points y will be
How do
0.
you know where how deep it goes then?
You tell me, think about it. I know that x at x minus 2.5, it reached the bottommost where the slope is 0.
Oh, he have to find the length of that one and up, like up one.
Yeah, length, how do you know this length?
Yeah.
So this is minus 2.5,
Hmm?
comma something. That will give y, isn't it? X axis, comma something.
Y.
Hmm?
No, keep
Ah,
y.
comma y, okay.
Y equal to 0.
Why?
You
If I
need to
put y
y-
is equal
you
to
need
0,
to-
then at
you
this
need to
point y
find the
cannot be
y.
0. Where
Oh.
y will be 0? Only on x axis it will be 0.
You need to find
Equal
y.
to x. Equal to
Think about it. Yeah, you can track it. Okay, so what is the point of? Okay, so we know at x is equal to minus 2.5, it reaches the lowest bottom, because at this point the slope is considered to be 0, because we know that it's rising, it's falling here, and then the slope has become
Yeah, then
0,
we
and then again
can
it is
do the
rising.
dy bump high d.
Tell me,
dx
what is
equal-
this point here? This point is some point on the line,
Mhm.
which is obeying this equation.
Yeah.
This is another point which is obeying this equation. This is another point which is obeying this equation.
Mhm.
This is another point. That is why I equated to 0. I got the roots.
No, wait. dy by dx equal to like like equate to that one, like the equation down there.
No.
Okay.
See, this is point. This is point. This is point. All these are points on the line, curved line.
Mm.
Okay.
Mm.
This is also another point. And this point we know, by looking at it, we know that this is meeting x-axis. That is why y is equal to 0. If you put y as 0, you will get the roots.
Yeah.
Okay. If I put this as a 0, I'll get the roots. This and this.
Mm.
If I put a y, it represents the whole line,
Whole curve.
whole
equation.
curve. Okay. If
Yeah.
I put in place of 0,
Mm.
if I put y, that will represent the whole line.
Mm.
This is also one point on the line.
Mm. Yeah.
This is also another point. This is also another point. This is also another point.
Mm.
Okay. Okay.
Okay.
How I got to know minus 1 here? If I equate this to 0, y as 0, because y as 0 I equated to
Mm.
0, then I got to know y x as minus 1, x as minus 4.
Yeah. Okay.
I know here at this point x is minus 2.5. What is the value of y? You simply put 2.5 here in this equation.
Yeah.
This is the line. This is the line equation. Every point obeys this equation.
Yeah.
Every
Then
point,
I'm
whether this is
saying
this
that-
point, that point, that point, this point, this point, every point obeys this equation. Follow this equation. To know what is the value of y, you know x. What is the value of y? Simply put x as minus 2.5.
Easy.
Easy peasy.
What?
Easy. It's very easy, Chelly.
Say again once.
Hmm?
No, like say again.
Put value of x as here minus 2.5.
Uh-huh. Minus 2. Okay.
Okay. Simplify it, you will get to know.
Oh,
You will
okay.
get to know. Okay, maybe roughly we can estimate it.
Oh my god.
You got it, no? Okay, 2.5 minus 2.5 square. 2.5 into 2.5, 6.25.
Yeah.
6.2.5 square is 6.25
2.5 square
plus
yeah.
5 into 2.5. 5 into
5.
5 into minus 2.5. 5 2s are 10, minus 12.5.
Yeah.
Minus 12.5 plus 4. Okay.
Mhm.
This one is 10.25
Mhm.
minus 12.5.
Mm. Okay.
If you subtract this one, you will get 1 point. Sorry, 2.25.
Yeah.
minus 2.25.
Point.
Minus 2.25. So the value of here is minus
Wait.
So easy.
minus 2.25. That is minus 2 1 by 4.
So easy.
It's not like up one. No, like with the subtraction again one.
See, I added this and this.
Yeah.
10.25 and minus 12.5.
Yeah.
Minus
But
12.5
equal to.
plus 10.25.
No, it's not plus. It is
Minus,
minus.
that's why, yeah. It is minus only.
no like wood. Wood. What one on like board like
12.5
one.
minus 10.25.
What? No, you did the other way around.
I'm subtracting the higher one from the lower one.
Oh, okay, I thought it's okay. And
Here,
how
because
I
it,
got
the
it.
higher one is negative, so I put minus 2 1 by 4. Minus 2.25, which is equal to minus 2 1 by 4. This is also working, right? Because obviously this will be negative only, because this is negative y-axis, negative part of the y-axis. So I got a minus 2 1 by 4. So it is the lowest value of y. Lowest value of y. That is why the quadratic equation has
Two squares like
only certain quadratic equations only will follow. For example, if I put for the same quadratic equation, if I put y as instead of minus 2.5, if I put y as minus 3.
Then x will also change. X will
No, if I put y as here minus 3. See, here if I put y as minus 3.
Wait, first of all, what is x? X is this direction, y is that direction.
Y is that direction.
But
So the lowest point of y, this is y-axis. The lowest point, this
can-
curve line.
no, we can still equate like minus 3 equal no like
Minus 3
it will
equated to
come
this
like
one.
that and
Equated to
come
that one.
whole plus
But
3.
do we get the roots?
Yeah,
can
it
we
will
solve
be
it?
Same.
No, you cannot solve it. We
No,
cannot solve it.
because
1 second. Give me an opportunity. Okay. So this curved line is following this route, and at minus 2 1 by 4 it reached the bottom most, and then again it will turn up.
yeah,
Okay. If I equate y as instead of minus 2.5, any value you can put above. That is fine. I agree. But if I put y as minus 3 here, y as minus 3 here, if I try to solve this equation, I cannot solve it. This equation,
Why?
solving this equation, because nowhere here, this curve is not reaching this point, minus 3 point.
no.
Minus 2.5 is here. Minus 2 1 by 4, sorry, not 2.5. Minus 2 1 by 4 is this here. Minus 2.5 is the x-axis here. That is the lowest bottom. The lowest bottom.
I think
No.
you told it.
Minus
has
2
to-
1 by 4.
In that bracket, it has to be first minus 2 1 by 4 and
No.
then.
No, first is x-axis, no? And then the y-axis. The y value we got from here is
No, like how am I saying is that like the down one
No.
like
Your question is minus 2 1 by 4. No?
minus 2 1 by 4
Your
is
question
the,
is how deep it is. Huh? How deep it is.
yeah, at this point it reached the
Okay.
lowest point.
Okay, I understood.
Lowest.
I understood.
At this point it reached the lowest,
mm,
and then again it turned up.
mm,
Okay, it is okay. Maybe if you consider from this side, it has fallen down, down, down. At this point, it reached the lowest, and then again it turned up.
mm,
Okay.
Okay.
So if I want to equate this equation to 3,
mm,
so the 3 may be somewhere here.
mm,
Okay. If I try to equate that to 3, I cannot solve that equation because nowhere in this line y is reaching a minus 3.
okay.
That is why at certain values of y, you cannot solve the quadratic equation.
Mm,
You know, b square minus 4ac, if it becomes negative, can you solve it?
No.
it will come
No.
I
Yeah,
Yeah,
you cannot solve it.
Complex number.
This is also the same case.
mm,
if you put minus 3 here, you cannot solve it because this line is not passing through minus 3 at all. It's never reaching the y value as minus 3.
Okay, okay.
-3 as x,
Y as a minus 3.
Oh, okay.
But any point, like if you put y as here maybe 10, y as here 15, y as here, sorry, here 15, here 10, here 5, something, any value you put it. Y as 20, you put it. Y as 30, you'll put it. For all of them, you're finding the solutions. X value, how much is the x value? You can solve that one.
Yeah.
But if you put y as minus 3, you cannot solve it. If you put y as minus 5, can you solve it?
No.
You cannot solve it. If you put y as minus 2.5,
No. Yeah.
no, you
Is
cannot.
x and y coordinate
Okay.
points?
Hmm?
X and y in that equation are coordinate points.
Coordinate points, yeah.
Okay. Then what is x in that one? Slope, That is the slope.
What is the x here? No, this is the slope. Whole thing is the
That is
slope.
the
If you equate
We
this
did
The x in
equation,
the slope is also a quadratic equation, no? Quadratic coordinate point, no? X in the
no,
slope.
see, this is the slope. We equated the slope to 0 to find out the lowest point of x. At what point of x it is reaching the lowest point? Because at this point the slope is 0. Isn't it? By looking at it, we are knowing like it is falling. Here, at this point, slope has become
Yeah,
0. That
because
particular point,
like small line.
point. Okay, at that point it has become 0, and then again started rising.
Mhm.
Okay,
Yeah.
that's why we equated this equation, the slope to 0, to find out the value of x, and the value of x is minus 2.5. Okay,
Okay.
minus 2.5, it reached the lowest. To find out the corresponding y, this is one point on the straight line, on the line, on the curved line. To find out the corresponding y, we equated this. We put a value of x as a minus 2.5 in this equation,
Okay.
and we got to know the y.
Then what if we equate to 0 then?
If you equate to 0, you'll get a x as a minus 1.
Then how it is coming, but if it like 2-3 minutes it can't come.
It can't come because this equation, this line is following only this route.
Okay.
This curved line is only following this route.
Yeah.
This curved line is not falling below this one.
Oh, okay.
So at value anywhere between anywhere below minus 2 1/4, you cannot solve that equation.
Okay.
It is not possible because this is the lowest point.
But if it 2,
If it is 2, you can
Then
solve.
we can,
If it is minus 2, you can solve it. If it is
Yeah.
2 also, you can solve it. So 2 is a
Yeah.
positive.
Yeah.
If it is minus 2,
How do you know how up it is? You know how deep it is?
up there is no
Yeah.
limit.
Yeah, it will be like
It is no limit.
infinite.
Any value of a positive y, you can solve it.
Yeah.
Okay, only up to this point from minus 2 1/4 to
So
Yeah,
what
above.
we are telling is y can't be -3.
y can't be minus 3, y can't be minus 5, y can't be
Because
minus 6.
it is
It can only be
plus.
until -2 1/4.
2 1/4 or above.
Yes.
Yeah.
Minus 2 1/4 or above. Then only you can solve this equation. Only if you put y as minus 2 1/4 or above, then only you can solve this equation. Otherwise, you can't solve this equation.
Okay.
That is why certain values, certain quadratic equation. If I put minus 2.5, minus 3, if I put y as minus 3 here,
Then
this
you.
becomes one quadratic equation, right?
Okay.
X square plus 5x plus 7 is equal to 0. That is one quadratic equation. If I equate to 0, then it becomes a quadratic equation. That equation you cannot solve it.
Okay.
The reason for that equation, b square minus 4ac will be less than 0. If b square minus 4ac is less than 0, you cannot solve such equations.
Yeah.
And the reason why certain quadratic equations you cannot solve is because of that.
Go.
Every quadratic equation, if you equate it to y instead of 0, that will follow certain curved path. Curved path, and that curved path will have at some lowest point. It only has some reason of y. Okay. It only has some reason of y.
If it like up like that, like.
What is the value of y here? Y can be anywhere here. See, at this point we have y. At this point we have y. At this point we have y.
Yeah.
At this point, is the curve passing? No, it's not curve passing. At this point, is the curve passing? No, it is not passing.
But what if it is like this one? like this form, like n, maybe like n.
Yeah.
Then
Yeah. Good. 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 Okay. Okay. I'm going to erase this one. For example, a line passing like this.
yeah.
Okay. So here randomly you pick any positive value of x. What can be x?
X will be
3.
5. Okay, 3.
Here it can be
Minus
1.
2.
Minus 1.
Okay.
And
And
here it can be minus 4.
7. Sorry, minus 4. Okay.
Minus 4. Okay.
Okay.
Minus 4. Okay. So what are the roots here?
X plus 4, x plus 1.
No, the roots are, you have to say roots are 3,
Oh,
minus 1
okay,
and minus
okay.
4. Those are the roots. And the factors, based on the roots,
Plus
you can
4.
find out the factors.
Plus 4 plus 1 minus 3.
Plus 4. Yeah. So x plus 4
Bracket x
plus 1,
it has to be square brackets
x minus 3.
because
Okay.
yeah.
These are the factors.
Yeah.
If you multiply all these factors, you will get an expression. That expression, if you equate it to y,
Mm-hmm.
you will get
Mm-hmm.
the equation for the whole line. If you
Okay.
equate it to y, you will get the equation. If you equate it to 0, you will
It
get
will
these
come
roots.
only the points.
Points, because y at this point y is 0. If you equate it to 0, you will get these roots. X
Yeah.
is minus 4, x is minus 1, x is 3.
Mm-hmm.
If you equate it to y, that will represent the whole line, a whole curved line.
Mm-hmm.
Okay, this is having a power 3, x power 3, the maximum. What is the power of x here in this whole expression?
3.
You. What is the power of x? If you expand this equation, what will be the power of x, maximum power of x? 3.
Because
Why? 3 terms are there. 3 terms are there because 3 roots are there. The power is 3. That is an odd power. That is an odd power. One arm will
it
go
will
up,
come up and down.
one arm will go down. Okay, those are the rules that we discussed. Okay, so if you expand this one, you will get an expression. So let's expand this. Let's multiply this one. X
X
square.
cube.
No, let's
Okay.
expand
Okay,
this one.
okay.
5x. I'm not that fast. Please bear with me. Okay, I cannot multiply all at one go. Okay. All right. Yeah. So.
X cube.
You know how we got this one?
Yeah. X cube
X cube
plus
5x square
5x square
4x
plus 4
minus
4x
3x square
plus
minus 15x
minus.
minus 12.
It
Okay.
came so much long.
If I simplify this one, x cube plus
And
2x square
yeah, 2x square
minus 11x
Minus 12.
minus 12. Okay, so this is y. Y is equal to x cube plus 2x square minus 11x minus 12 represents the whole line. If I put a y as 0, you will get this
only
point.
the points. Yeah.
X values, you will get 3 x values. Those x values are this one, this one, this one.
Mhm.
If I put instead of a 0, if I put y, that will represent the whole thing. These are all the various points on the line, on this line. This point, this point, this point, this point, this point, this point, this point. All
Like
are
each
points.
point, like
Each point will follow this equation. For example, here, what do you think of x? X will be
X
maybe
will
the
be
3 and a half.
3.5. Yeah.
You put a value of x, you will get to know the value of y.
Okay.
Okay.
Hmm.
At this point, what do you think to the value of y? Maybe
y-
minus 1 or something like
Yeah,
that. Okay, we
minus
don't know.
1.
Assume that y is minus 1. Put a value of minus 1 and solve it, you will get to know the value of x.
But
Okay.
it may be the below the peak point of that, like the peak point. No, like down.
So at this point, what is the value of y? It could be minus 1.
Highness of 1.5 maybe.
Minus 1.5, minus
Yeah,
1.
because
You put a value of y as a minus 1
yeah.
and solve this one.
Mm-hmm.
You will get the value of x. How many x's you will get if you equate it to minus 1?
It 1.
No, you will get again 3.
Yeah, 3x.
Okay.
3x. What are those points? This is 1 point. This is 1 point.
Point.
This is 1 point. For all of this, y is 1 only. Y is minus 1 only, right?
But it has to be the same, right? X has to be the same.
Yeah, it
Because there are
should be
no-
same.
No, x will be different. If you equate this y as minus 1,
Hmm.
you'll get the 3x values.
Hmm.
If you put y as minus 1,
Yeah.
equate it to 0. Take it to the other side and it becomes a 0. If you solve it, you'll get 3x's.
Hmm.
Okay?
Okay.
3x's.
Okay.
If I put y as minus 1, you'll get 3x's. What are those x's? Here, at this point. Here. See, at all this point, y is minus 1 only. This point also, it is minus 1.
Hmm.
This point minus 1. This point minus 1. This point is also minus 1. At this,
Hmm.
y is minus 1. Here, minus 1. Here, minus 1. Here, minus 1.
Hmm.
So the corresponding, there will be 1 x. Corresponding, there will be
I
1
have a
x.
doubt, but what if it is like the down in the y-axis? Like, no, wait.
Okay, so at this point, we have,
Hmm.
if I put a y as minus 1, if you solve it, you will get a 3x's.
Hmm.
This is 1, this is another one, this is another one.
Yeah.
Alright, yeah. So let's go back to differentiation. Our original concept where we started this whole session is with. Okay, let's differentiate y is equal to this one. Let's differentiate on both sides with respect to x. D by dx is equal to
Hmm.
d by dx of x cube plus 2x square minus 11x minus 12. If I differentiate this one, I can expand it. You know that, right? Differentiation of x cube plus differentiation of 2x square plus differentiation of minus 11x plus differentiation of minus 12. If I differentiate x cube, what will I get?
It will come dx
If I differentiate
dx cube by d. Sorry,
dx
d
cube plus 2d.
d by dx. Yeah.
x cube.
Yeah. Cube.
Okay, I thought you will be able to tell
Looks-
without expanding it, but anyway, I am expanding further. 11x minus d by dx of 12.
Yeah. Down. What's what I said? Dx cube.
Okay, Krishna, you tell me what is the differentiation of x cube with respect to x?
3 into d
Mm.
by dx.
Hmm?
d by dx.
Mm.
3 into x to the power of 3 minus 1.
After putting that one, there is no need to put d by dx. Why you are putting again d by dx? There is no need to put d by
Okay,
dx.
3 into x to the
square.
power of 2. And next is 2 into 2.
2 into 2,
2 into 2 into x to the power of 1.
1, yeah. Minus
Minus
11x.
11 into
1.
yeah
Differentiation of
1
x
into okay
And
tomorrow-
0.
0. Okay. So 3x square
What is it then? d by dx minus 12.
d by
It becomes 0.
minus 0
Constant.
plus 4x
Mhm.
minus 11. This is the dy by dx.
Yeah. It's like the quadratic equation.
Yeah. This represents the slope.
Slope. Yeah.
Okay. What will this represent?
It is
The
like
line
each
equation.
point.
Line. Each point.
Oh,
Yeah.
line
It
equation.
satisfies the whole every point.
Each
on
point.
the-
Yeah.
Is that
Every
the line
Point.
equation?
Like.
This is the line equation.
That is a slope.
That is the slope equation. Again,
Normally in a straight line we just say that slope is a simple number.
simple number.
But in this case it's like a
In this case, it is an equation. Okay,
expression.
because it does not have a fixed slope. It is
Yeah.
varying with respect to x. Like at this point of x, we have one. At this point of x, we have another slope. At this point, of course, we need two points.
Mm-hmm.
But
But
if you-
it is so small.
so small, yeah. X is x. If you take minus 2, just to minus 2.00001
Mm.
minus 2.00002. Take those 2 points and then find out the slope.
Mm.
And the
Got
slope at those 2 points and the one that you get using this equation at x as 2 minus 2, both will be same.
Okay.
Okay, they will be nearly same. Yeah, if not same, but they're close to same. Like, okay. So what are the points? So okay, in this equation, where do you think the slope is the least?
There.
Like
There.
Here.
no, it's not there. It is outside, like the down one.
Point.
No,
Yes, there only and up there.
Okay. Somewhere here maybe.
and also like the no, it's not up one. Like mine minus four is there. No,
Hmm.
I peak down.
Here.
Yeah, like no, it will go like minus infinite.
But here it is rising, right? It is rising.
No,
Why do you think
but
the slope?
at even the
Yeah, it is here. At this point, the slope is 0. It is moved up.
That
With some
not
slope,
necessarily
it
has
is
to be
there.
down itself. It can be up also there. It doesn't.
See, it is moving with some certain slope, with a certain rate of change. At this point,
Oh, you're thinking
Yeah.
that one has to be only down below
No,
x. It
not
can be
that.
above x.
see, look at the here. See the slope between the 2 points. See, it is rising. It is rising. It is rising. It
You
is rising. But here, at this point, at this particular point,
okay. Mm. Yeah.
particular point, the slope has become 0 and then again turned down.
Yeah.
Yeah. Okay. So at this point and this point, the slope has become 0.
Mm.
Okay. If you equate this slope to 0, how many x's you will get?
Two.
2 x's.
Yeah.
Because this is a
because
quadratic
X,
equation.
Yeah.
We'll get two x's. What are those x's? This is 1x.
Mm.
Somewhere here. Maybe 0 or maybe
Mm.
here. Okay. Okay. You know what? We'll get 1. We'll get 1. Here. Sorry, 1. Yeah. I think at 1 it will be 0. Because this will be.
Okay.
I think
Yeah.
at 1 it will be 0. The slope will be 0.
Okay.
Because what is the middle point between -1 and 3?
1 and
Middle
One.
point.
Yeah, middle point. -1 and 3. What is the middle point?
1.
1. Yes.
1. Yeah.
One.
Okay. And here, what is the middle point between -1 and minus 4?
Minus 3. Sorry.
Minus
sorry.
2 and a half.
Minus 2
Minus
and a half.
2 and a half.
Minus 2 and a half.
It will
Okay.
be somewhere. Yeah.
Shall we solve this one? We will see. Okay, -33. Okay, shall we do it via this one? B square minus 4ac. Okay. -4
Minus 4.
plus or minus b
Plus or
square
minus under root
4
4
A.
square.
c by
2.
2 into 3 -4 plus or minus square root of 16 12 11s are 120 132 plus 132 by 6 -4
Minus
plus
4
or
plus or
minus
minus.
square root of
Mm,
how much 8
14.
148
and
Yeah.
48.
14. 8. Yeah. Something.
by 6
So minus
The square root
square root of 148 is it 12? Square root of 148 is 12.
1.4 right.
It will come 12 points
You
something.
can just see in the calculator.
Hmm?
Square.
12 point. You have the calculator. Yeah. So if I do it via this perfect roots method, we'll get 2 roots, and one of the root is -1. Sorry, one of the root is 1.36. So somewhere here at 1.36,
Mm.
at this value of x, it is reached at the bottommost.
Mm.
Similarly, if you put here, if you take a minus symbol,
Mm.
then you will get between these 2 points, you will get the
Mm.
peakmost.
Peak.
Peakmost. Like it's
No,
not the
no,
peakmost,
it
it is
has
the
to be-
point at which the slope is 0.
Yeah. Yeah.
This point and this point, these are the 2 points where the slope is 0.
If
So
it
to get those points, what you have to do, you have to equate that slope equation to 0.
okay.
Why you are equating that slope equation? Because at
To
this,
find.
because to find out the value of x at which the slope is 0.
Yeah.
Once you know the value of x, you know that 1.36, at 1.36 it is reached at the bottommost. To know that value of here, to know that value
Yeah.
of y at this 1.36, you put the value of x as 1.36 here,
Mm. Okay.
and you simplify this one, you will get the value of y. and y will be
So
here. We'll get a-
1.36 is what?
1.36
how
is the
much?
point of
Okay.
coordinate of x on this line at which the slope is zero. The
That means
slope is
1.36 y. Y is
Why?
1.36.
No, x is 1.36
Oh.
because we equated x this
Okay.
whole thing to x and thereby we solved the value of x.
So we need to find y now.
Why? How do you find out the value of y?
Just put 1.36 in that equation.
No, not in this equation.
No, in the up
In that
equation.
Yeah, the value of x is 1.36. So what?
Yeah, then equate the that one into the x.
If you put here 1.36 here in
Yeah.
the place of value, you'll get 0 only. What is there to solve it? This is the slope
No,
equation.
I equal to I equal to
Y, okay, y is equal to this much. If you put the value of x as 1.36, you'll get y as 0 only.
okay.
That's why don't confuse with this equation and this equation.
Oh, it has to be up equation. Yeah, up equation.
This is the slope.
Yeah.
This is dy by dx. This is one equation. This is y. Y is equal to x cube plus 2x square minus 11x minus 12.
Oh, means it has
This
to
is
be
dy
up.
by dx, which is equal to 3x square plus 4x
It has
minus
to
11.
be up.
Okay. This represents the whole line.
Whole
This represents
whole curve.
this represents only the slope.
Mhm.
I did not draw this line.
Okay.
I did not draw this line. This also represents one line.
Mm.
That represents the slope of this whole line. Okay?
Yeah.
That represents the slope of this whole line.
Mm.
Again, so you figured out the value of x as one of the value of x here is 1.36. To know the corresponding y on this here, how do you get? You put value of x
In up equation.
in
Yeah.
this equation.
There.
If you put value of x as 1.36, you will get some y, and that y is here.
Mm.
Similarly, you take a negative value, you will get some other x. You put the value of x here, you will get a corresponding
Same.
y. Corresponding y.
Yeah.
Here you will get two values, right? One plus 1.36. If you take minus
There
value,
also you will put that equation only, yeah? If you want to know there.
yeah, here only we have to put. Because every point on this point, whether it is a peak point or low point or any
No,
point,
my question is there you took those that equation, found the
1.36 I put here.
no, this equation you found the factors of it and put it there, no? You used the completing square method, no?
Hmm.
For that, which one you will use as completing square method?
This only. If I use plus,
Yeah.
I got a
Yeah.
Oh,
I got a 1.36. If I put a minus, I'll get something else. That may be somewhere minus 2 point or
I think you
something.
should take minus here, not this.
Yeah, correct. Minus 2.5 or something like that. Assuming that you will get a minus 2.5. Minus 2.5. Put value of x
No,
as
that
minus.
minus has to be here and plus has to be there.
Why? The value of x here it will be positive.
Oh, like that. Okay.
At this point, and this point is here x.
Yeah. I got it.
Positive. Okay?
I got it. Yeah.
And here, the value of x will be negative.
Yeah.
Okay, and the corresponding point
Mm.
x is negative. And if you put this value of x as minus 2.5 here, you will get a y, and this y, this y, this y. You put a value of x as minus 2.5, you will get a y, and that is this y.
Okay. Yeah.
So that's the beauty of this differentiation. The differentiation will tell the rate of change for any given equation. One thing, if you notice, if the given equation is having a power 3, and the differentiation will be 1 lesser.
Yeah.
That is why, what is the maximum power of y is equal to 3x plus 5? What is the maximum power of x here?
X is 2.
X is 1.
Oh,
Maximum
okay.
power of
1.
x is 1.
1.
And the slope of this one, dy by dx, what should be the power of x?
2.
0. 1 less.
No, because
No, Ray,
for
I'm talking
that
about
one-
this one.
Oh, it's only the plain one is 0. And
1 less. That
minus
becomes,
1.
that is why it becomes a 5. Answer is,
it
sorry,
becomes 0.
answer is 3.
Yeah. Yeah, then it becomes 0. Like
Yeah. What is the power of x here?
0.
0.
Yeah. 0.
What is the power of x here?
0.
0. What is the power of x here?
1.
Maximum power of x.
1.
1. If you reduce by 1, here it is 0.
Yeah.
That's fine. Here the maximum power of x is the curved line. Maximum power of x is 3. And the slope equation, the maximum power is 2. It is 1 lesser. Okay. There are a number of formulas. Like this is a one formula, but there are a number of other formulas like differentiation of sine theta with respect to theta,
And cos theta.
cos theta, and the
and
differentiation
theta,
of logarithmics, and differentiation of
Cosecant,
various things, various formulas. But
cot.
this is the one we most often use to understand the concepts of the differentiation. This is how the differentiation works. Differentiation tell the point at which
Yeah.
the differentiation tells the rate of change. Rate of change with respect to x, dy by dx. Why x is varying with respect to x, as we're moving x here. What is the value? See, from here to here, what is the x? This is the x moved here. What is the y? This is the y. This is the y moved.
Yeah.
Okay, rate of change. But at this point, particular point,
Like the peak point.
peak or bottommost or peak
Okay.
point, at this point, without becoming a slope 0, it cannot take a reverse turn.
Oh,
Okay.
like if it like a rare.
For example, if
Reverse,
you're
so
going
we
to
have
one
to
place
stop
and returning it, you have to stop it. That
Yeah.
means your speed has become a 0.
Yeah, stop and then
You returned it.
again come back.
Yeah, without making your slope, without making your
But
speed
we
0,
can, but we can because smoothly it can go like that.
smoothly.
No, like if a car is there, if it go like smoothly, like you.
Even if it
you
goes
don't-
smoothly, at some point of time,
Uh,
the slope
Yeah.
has to become a 0.
it no need to be 0 because like smoothly it has to go like that.
So smoothly correct.
Here we're
But
talking
what
about
axis
straight
you are
line.
taking, it is also matters.
Here we're talking about straight line only. Straight line only.
No, it's not a straight line, it's a curved line.
Yeah.
Curved line.
Okay.
Okay?
But that curved line also should be in straightly like this, not in round.
For example, okay, you said that car is going in a smooth shape turn. I agree. Okay, so the car is going this way, this way, this way, and this way. Okay?
Yeah.
Okay?
Yeah.
With respect to this, with respect
Yeah,
to this axis, okay?
Mhm.
With respect to this axis, this is a distance,
Time.
this is a time.
And
We're differentiating with respect to time.
velocity.
With respect to
There
time.
is stopping. There it
Okay,
is.
this one you say D.
Exact.
Differentiation of S, maybe S, you put it as a displacement with respect to T.
Okay.
At certain point here, with respect to time,
Yeah.
with respect to time,
Yeah.
it is not moving. It is not moving, it is not making more distance here.
Oh, okay. But what if it's like a big plane of a ground and then the smooth road is there? Like nobody are there inside.
Even at this point, there is one peak point here, somewhere
Oh,
here.
okay.
Okay. The change of distance here, if you go up, it is the distance is changing. But is the distance changing here? Though he is traveling, though he is maintaining the speed,
Yeah.
but this direction on y-axis, okay,
Yeah.
the rate of y-axis, the rate of change of y-axis with respect to x-axis,
Okay.
certainly at some point, if not here, there is some point here, certainly it should be 0.
Okay.
The points around it, the slope will be close to 0. Around, sorry, at this point, assume that the slope is 0. Maybe this point, the slope is close to 0. Here, the slope is falling negative, negative, negative. Here, the slope is
It
rising,
is
positive,
rising
positive.
rise by run.
Rise by run, yeah. Rise by.
Actually, how do we do that one?
Say for example, we take these 2 points. What is the rise here?
Um.
See, this is y is the rise. Y axis is
Okay.
rise. This is rise.
Mhm.
And the run is this one.
Oh, okay, okay.
Running part is this one.
Hmm.
Right, how much it changed? Y-axis, how
Oh,
much
that
it changed?
by that one. Yeah, yeah,
This
yeah. I
branch.
got it. Yeah.
Alright, yeah, this is all about the differentiation. Hope you enjoyed this one. We'll meet up again. Thank you.